to a molecule, and I actually picked a molecule that it's not going to work for, even though it would work even just at this level for many, many molecules. And I picked looking at methane so we could see if there are other factors that we're not considering that we need to maybe tweak our model a little bit. And I think we'll find that we do if we take a look at a polyatomic molecule, methane, so CH4. So let's think about methane using valence bond theory. So using our simple valence bond theory, what we would expect is that we want to pair up any unpaired electrons in methane with unpaired electrons from hydrogen and form bonds. But what we see we have is that we only have 2 unpaired electrons here, because we have a paired set in a 2s orbital, so all we're left essentially is 2 electrons that are available for bonding. So this should immediately look like a problem, because we know, in fact, that methane is tetravalent, and this is telling us that it's only divalent. Essentially, it would only allow for us to bond to 2 hydrogen atoms. So if it did this, it now looks like, from looking at the paired electrons, that we have a stable structure here. And our structure is not CH4. It's a stable structure of CH2. And it will actually predict also what this HCH bond angle it is. So according to this model, what is that bond angle? One more time. OK, I hear a mix. So according to this model, what we're seeing is a bond angle of 90 degrees. What do you know the bond angle should be? It's 109.5 is what we would expect for methane, because it's tetravalent. But here we're just seeing something that's divalent, and they're both in p orbitals that are perpendicular to each other. So what we're predicting is a bond angle of 90 degrees. This is totally wrong. This is the wrong picture altogether. If you had your notes, you could do some fun scribbling right now, so you can do that at home. We're going to need to tweak our explanation here and take into account another factor, and that factor is the fact that we know that we must have 4 unpaired electrons in carbon if we're going to form 4 bonds.